We love senior things with Jostens. All right, here we go. A little warm up today. We're going to start with a quotient rule. We should see this immediately as a rational, and in our heads, we should immediately see that its domain is all reals except for +3, right? Because we should be able to easily identify the vertical asymptote on this one. That's not important to this problem, though. And we have to recall the quotient rule, which I already made big here, that when I have two polynomials, a rational expression, I can do f over g, and it's the derivative is f prime g minus g prime f all over g squared, where f prime is the derivative of f, and g prime is the derivative of g. And everybody, I can't stress this enough, you are picking this f and g. It is not this f of x, right? Every year students get confused. This is going to be f in this case, and the bottom is going to be g in this case. F prime is still the function, but the rule is just set around f and g. You have to separate those two. That said, you pick those and you find f prime and g prime using the power rule. So the top is 2x squared minus 4x, that's f. So f prime is the derivative of just that portion, 4x minus 4. G of x is the bottom, negative x plus 3. G prime is just the derivative of negative x, which is negative 1. And then you just got to fill in our quotient rule. And I did that here in red. And it is big and ugly. And every time, if I'm grading tests, guys, I do look for this step. Did you do it right? Because now it is just algebra. Important algebra, but just algebra. You know, grab an algebra 2 student, start multiplying binomials. See if I can do it without making a mistake today. I have not been on a roll today. And I am not going to multiply out the bottom. We rarely do. So I get f prime of x equals 4x negative 4x squared negative 2x squared plus 12x minus 12 all over negative x plus 3 quantity squared. And I suppose I could try to pull a 2 out of there and see if it factors, but it doesn't from the looks of it, because I'm going to get 6 and 6. It's not going to factor. So I'm not even going to pull the big 2 out. Guys, that's the answer. All right, that is the answer. Did somebody else get that here in the class? Yeah?
It's okay if I expand the dot now.
Yeah, it's okay. You're just working too hard. So you would have had this. You would have had x squared minus 6x plus 9. Yeah, that's fine. Nice part about that is if you write it as x minus 3 squared too, factor the negative out. But nice problem, and pretty straightforward. So that's the quotient rule. And again, everybody on my test, I asked for this. This is 10 free points. Well, not even free points. You got to get these 10 points, because without that, you got to have that. So I make it a mandatory skill. No, not in chapter 1 or 2. This will be chapter 3. From there out, though, every time. The front cover never changes. I just mix it up in order. Because I've had people try to memorize the front page in order. So I mix it up every time. Everybody, remember on g of x, I do not want to do the product rule. For a reminder, here's the product rule, and I do not want you to use it, right? We did one like this last week. If you have this, it is f prime g plus g prime f. That is the product rule. And again, another rule you'll have to have completely down, but we're not going to use that for g of x. If you're not sure where to start, all right, on g of x, find g prime. I need rational exponents, all right? There we go. All right, everybody, I know the product rule will work. Don't do it, all right? I make a joke at Juda all the time. When you hang a picture on the wall, you can slam your thumb with a hammer, right? You shouldn't do it. If you're nailing a nail up, you can take it, if you want, you can put your big old thumb out, right? Take out the big old hammer and go, ouch! But why do it? Guys, using the product rule in this case is like slamming your finger with a hammer on purpose. We've used algebra 2. We know that square root of x is x to the half. We know that the cube root of x is x to the 1/3 minus 1. We'll use our distributive property from algebra 1. Oh my God, all this stuff keeps coming back. Half plus a third, last time I checked, that's going to be x to the 5/6. 1/2 plus 1/3, distribute to x half. Now, my number one mistake I get with students is they write x to the 1/6 there. Remember, when you multiply bases, you add exponents. X squared times x cubed is not x6, it's x5. Now, it's as simple as taking the derivative. 5/6 times x, 5/6 minus 1 is negative 1/6, minus 1/2, x to the negative 1/2. Everybody, that would be in negative exponents. Now, you probably aren't going to live with that, all right? Oh, I know, I'm killing you. So now here we go. I'll probably write it on a multiple choice test, which I love giving. I love it. I'd probably give you this. This is probably what I would show. I'd be nice. You know why I'd be nice? Because I probably would not make a common denominator, which I could do. Can you imagine? I could say 6x½ here, couldn't I? Oh my gosh, how ugly would that be? Okay, listen, we're not going to, but listen, there's a derivative in green. Everybody, I don't know if fooled anybody. Pi times pi squared is constant. Derivative of any constant is 0. H prime is a 2-second problem. When it takes you more than 2 seconds on chapter 3 test, not the next test, it will kill you because I put problems on there to make sure that we're speedy a little bit. All right, one more warm up today. Ball falls at h of t equals negative 12t minus 16t, where t's in seconds. And let's put h in meters. We hate. I suppose I actually wrote it for feet, but we'll do it in meters anyway. You guys from physics should recognize that. I want you to find the average velocity from time of 3 to time of 4, time of 3.5, and to time of 3 plus h seconds. And then I want the instantaneous velocity at t equals 3 and t equals 1. This is a setup. Which one should you do first? 3 plus h should be your first one. And actually, you might even argue that you should do a plus h, right?
Yes.
All right, so give it a chance. This is chapter 2. This is on the test, period. All right, it's coming. All right, so the trick to these problems is always the same thing. They're going to ask you to do a bunch of positions, and you should not fall for any of them. You should immediately recognize that the same equation, f of a plus h minus f of a over h, works for all of them. That is the average, and if you want it instantaneous, for part B, we're just going to put the limit as h goes to 0. So for the part 1, we're going to do that. We're going to say the limit as h goes to 0 for part 2. And we skip all A, B, and C, none of those, and we start with the red. And we say, hey, all right, we'll put this in. And we know what the answer is going to be pretty close because we can know that we can probably do the derivative for part B with the power rule. I'll make you do it out using the definition for chapter 2. So we'll write it out. So I'm going to do that in red here on the side. Negative 12 times a plus h minus 16 times a plus h squared. We'll need some more space than that. Minus, and then I'll put in parentheses so I don't screw up, negative 12a minus 16a squared, and those better disappear, right? All over h. I'm going to do them in colors. I'm going to do this one here, negative 12a minus 12h. And everybody, I am really good usually at doing the math here, so I'm going to try to skip a step because I think I can. And I should get plus 12a plus 16a squared all over h. And then I'll use my purple pen. Negative 12a, positive 12a, 16a squared, negative 16. And looky, everything that's left has an h. Oh, we're so surprised. No, we're not, right? Not anymore. Every time. So how about negative 12 minus 32a minus 16h? That would be the average velocity starting at time equals a, lasting for h seconds. So obviously all of them start at 3. Do you guys agree? So I'm going to make some space here, and I'm going to say, well, all the ones for part 1 start with a equals 3. Right? And I can put that in my calculator. Negative 12 minus 32 times 3. 32 times 3 is 96. So negative 108 minus 16h. And then I just have to decide the h values for A, B, and that's the answer for C. You guys agree? That's the answer for C.
C?
That would be C.
Oh, can you just get rid of the 16h or no?
No, because it was average. You're going to get rid of the 16h for instantaneous.
Okay.
So this is the answer to C right here. And I'll put meters per second. All right. Now for A and B, I got to do some legwork. For A, you have to catch that letter A. A is 3. Yes, it's really confusing because this A and this A aren't the same. I'm a bad teacher. And H is 1. I already put A in. H is 1. How about negative 124 meters per second for letter A? And then for letter B, I'm doing green. A is still 3 on the derivative equation, but now H is 1/2. So I get negative 116 meters per second. Because half of 16 is 8. 8 plus 108, 116, both negative. All right. Now I say find the velocity. Well, now I can use this limit I was saving, right? And I'm going to take the limit, and A is 3, so I'm going to use just, well, actually, I'm going to use this, because I have 2 different times there, 2 A values. Oh, yeah, Calista.
Okay, before we move on, this is gonna sound really stupid, but how did you get H as like 1 and like the other one's half?
Not a stupid question. I start at time equals 3, and I go to time equals 4. So,
The difference.
it's the difference. Remember, H is always that space between Q and P.
And so then the number that you're plugging in is gonna be the H.
Yes.
Okay.
Does that make more sense?
Yep.
Okay. Now, I'm going to use this for part B because the A changes in part B. Now, everybody, this is where H disappears. Because now, there is no denominator of 0. You just plug it in. And, so I said, right here, you froze. I come back to, I stole this because I have different A values in part 2. You see that?
Okay.
All right. And then I plug in H goes to 0 because I can just put it in because I got rid of H in the denominator. This just goes away. So then I just got to fill in A. A is 3 and A is 1. For time equals 3, I get negative 108 meters per second. For time equals 1, I get negative 44 meters per second. And that is the speed now. Boom. Instantaneous. And again, so Calista, if I go on, I think this is worth doing. I'm going to go dual page for a second, and I'll get it so you guys can see it. I want to be clear about this. The A value you're talking about, the A and H, all stem from this horrible graph we've drawn so many times. All right, and I'm going to draw it again because if you understand this, all right, and I do not care what the curve looks like between P and Q. This line is the average. And you can see that the distance is always starting at A and lasting for H seconds. So on one example, I had 3 to 4. H is 1. For the second one, it was 3 and 3.5, right? So H was 0.5. All right. And then the last one started at 3 and went to 3 plus H, which is still just H. And again, every time we do this, and then this is the average, and so if the curve looks like this, who cares what it looks like? But eventually we bring Q back to P, using a limit as H goes to 0. It all falls back to this. Okay? You want to do another one of these? Yes. All right, we can. I can make one up on the fly. I'm going to pause the video and I'll start again here. Hang on. All right. So there's the problem. Ball's thrown up. So now you notice the equation's different. Ball's thrown up, comes back to Earth. I'm going to make a graph just for fun. You don't need to. But obviously this is one of those problems again. I don't want to start with letter A, Roman numeral 1. Right? So again, jump on it, see what you get. I'll put the answer up in a second. So here we go with the answer, guys, and I have it start at the bottom. First of all, I don't want to do the conditions of A is 2 and actually durations. I want to do it in terms of all variables, right? And the instantaneous, or the average rate of change, sorry, is a secant line. It has 2 points, P and Q, so it's just rise over run. And it comes back to the graph we did here about 2 minutes ago on this video. And I have to plug in a plus h back into the original function. And I know the function's called h of t, and the function in our formula is f, but we know that that's the function we use. I do this math out down here, guys, and I have to expand all this, right? I got to get h to cancel. We know every time we do this, as long as it's a function, the h on the bottom will cancel. And if I do that, it looks like we get to 40 minus 32t minus 16h. That's after I do all the legwork, all right? And again, I'm just doing this a little faster because, again, this is review for us now. And that's just doing algebra 1. Expanding it, canceling, and then factoring and canceling. So there it is. But this time, like for Roman numeral 1, and the English is different this time. A is 2, H is 1 in Roman numeral 1, because I said starting at 2, lasting for 1 second. It's going from 2 to 3, so A is 1, A is 2, H is 1. So A is 2 gets you negative 24 minus 1, negative 40 feet per second. Then if I plug in 0.1, if I plug 2 in here again, I'm getting negative 24 minus, so negative 25.6, is that right? Feet per second. And negative 24 minus 0.16, so negative 24.16 feet per second. And again, I'm getting those values by using this formula where T is 2 and H is 1, or this would probably be A in our formula. I should have probably had A here. It depends if you did A of T. But alright, and then for H seconds, this is it. You can plug in 2 here and get negative 24 minus 16h feet per second for Roman numeral 4 from our formula. And then the only thing you got to do for letter B, and I'll do it in black right here, letter B, is take the limit of that expression you create. And it sends this packet. Bye-bye. Because it is a polynomial, you've made h disappear in the bottom, you can do it. And when you do that, the instantaneous rate of change, I get negative 24 feet per second. Alright? Guys, keep practicing. Tomorrow we're going to pick up with word problems on average rate of change. Right?